now starting. All attendees are in listen-only mode.
Hello everyone, very good evening to all of you. My name is Mayank. This is our first ever interaction. I have had history with Mindworks. 3-4 years ago I used to take classes. Then I took a short break, and now I'm back again. A little intro would be I completed my MBA from IMT Ghaziabad in 2009, and thereby starting my career as a full-time trainer for CAT. And I have uh, an experience of around 11 years teaching for so many entrance exams, primarily for MBA entrances, India and abroad. And I hope I'm audible, by the way. Okay, great. This is supposed to be an MDC class, math development class. Uh, so, we would rather uh, emphasize on the basics with a lot of examples, and our pace would be slow to moderate. And please guide me about the pace or the number of examples to be taken. I'll keep asking you, so please guide me about the flow of the class and all. So let us start. All right. When we say numbers, the what would be the first numbers that come to your mind? Often in the class, when I ask, uh, I mean, if there is a class of 40 students, say, and then I suddenly open up to them and then I ask them, okay, tell me a number. So suddenly asked, people respond to me like somebody says 7, somebody says 65, somebody says okay 5 and 24. So generally uh, the kind of responses that I get are comprising 1 or 2 digit numbers. Sometimes, very few times, people go to like 3 digits or 4 digits. Yeah. So my response to them is then, you know, I already had an idea the kind of numbers you would be telling me. So obviously, I'm not a magician. I do not know what numbers you were about to say, but I did have an idea as per my experience as to what kind of numbers you were about to say. So if you see, these numbers are all positive, then they are all integers, and further they are 1 or 2 digit numbers. So when I asked you the numbers, these are the numbers that came to your mind, right? These are the numbers that came to your mind. However, I then always think that what about 0? That is also a number. What about root 2 or log 3 or minus 10 or 1.25, right? Or pi or exponential e, etc. These are also numbers, but these numbers do not come to our mind. What comes to our mind are single digit or 2 digit positive integers. Now, there is a reason behind everything. Behind every bias, there is a reason. The reason is that everybody uses these numbers on daily basis, day and night. So, if you ask somebody walking on the road a number, the chances are the person will not tell you under root 3. Okay, so these are the numbers that we are used to. So if somebody buys a car, and if you ask them what is the cost of this car, hardly anybody would say it's like 7,56,478. Everybody says 7.5 lakhs. So we tend to summarize every number in terms of 1 digit or 2 digit numbers. But the world of numbers is vast. There are so many kinds of numbers. So the first classification that we are going to deal with is rational and irrational numbers. Okay, so let us now see rational and irrational numbers. So, okay, what does the book say about rational numbers? The bookish definition. So, the bookish definition of rational numbers is uh, a number which can be written in the form of p by q, whereas q is not equal to 0, is a rational number. So, any such number is like that. Okay, there is a small amendment, or you can say addition to this basic. I would also say that P and Q are integers. So Q is not equal to 0 and P and Q are integers. Because then anybody would say, okay, root 2 upon root 3. This should also be rational. But it is not, isn't it? So we have to be very, very clear and specific about this. So Hi, Abhishek. No, it's not like that. I'm going to cover only the sixth, seventh standard math. The level will rise. So just keep watching. Okay, the number is like 2 by 3 or minus 5 by 7, or what about 0? Is it rational? Yes, it is. And 5, etc. So what are the kind of irrational numbers? Under root 2, pi, e, 10th root of 4, etc. Okay, so, oh yes, log also. Log and sine and tan and cos. So log 3 suppose, etc. Fine. So can I say that any any of these numbers that I have written, they can be expressed in the form of p by q. So can I say that all integers are covered in rational numbers? Yes. All integers can be mentioned in the form of p by q. All fractions, so proper fractions, improper fractions, mixed fractions, vulgar fractions, whatever fractions. Okay, now there are two terms that I really want you to emphasize on. This was the idea, and that is why I started this topic of rational and irrational numbers. So there are two terms. One is terminating decimal, and fourth is recurring decimal. We'll be talking about this for the next 5-10 minutes. Terminating decimal. You know what a terminating decimal, as the name suggests. So let me take it here. As the name suggests, a decimal that would terminate. Like if you divide uh, 3 by 16, so we would start like this. Then how many times? 8 times, I suppose. Yeah, 128, 12, 127, 112. So every time there is a remainder, we put a 0 and we go into decimal. So finally the division ended, and we have a decimal like 0.1875. The division ended and it became a terminating decimal, right? All right. So whenever you divide a number by some divisor, and maybe after very long, but the division ends like it did in the example shown. Okay. So all those decimals are called terminating decimals. And yes, why won't they be? Why won't they be rational numbers? Because when you know how many digits are there and where they are ending, so you know that when you take off the decimal, how many zeros will be there in the denominator, isn't it? So suppose it's 3, 2, 4, 1, 7, 5, 8, 4, 2, whatever. And if you want to take off the decimal, then you know how many zeros to put in the denominator. So eventually it will be in the form of p by q. So it will be rational number. So all terminating decimals are rational number. Okay, so this is how we define terminating decimal. Now there is a special point. There is a special point. What the point is that let me type it for you, and then you may also note it down as a note, as a very special note, and you are expected to know this. Right now, this is a special point which is not present in the school books NCERT. Till now, whatever we have covered has been covered in NCERT, maybe in different words. But this is a special point that is a little different. So I'm writing it down. So, so any integer n, if divided by any combination of 2 and 5 or their exponents, rather let me write it down like or numbers made by raising 2 and 5 to powers will always result in a terminating decimal. Okay, let me explain it to you. So what it means is that if you divide any integer, positive or negative, doesn't matter. So suppose you divide uh, a number by 2 to the power a into 5 to the power b, the result will always be a terminating decimal. Okay, so even if it is an integer, it's a terminating decimal. Okay, terminating decimal means the division gets completed. Okay, so 2 to the power a, 5 to the power b. Now a and b are integers. Positive, negative, 0, doesn't matter. Okay, so suppose I divide 7 by 80. 80 is such a number, 2 to the power a, 5 to the power b. 80 is made up of only 2 and 5. So any number whose prime factors are 2 and 5, 2 or 5 I should say, it will always result in a terminating decimal. You can check taking your own example. Uh, Chandra Kamal asks, what if b is 0? That is okay. That is completely okay. See, in fact, we took an example in which b was 0. See, we took an example in which I divided 3 by 16. 16 is just like 2 to the power 4. So b was not present. Still, it ended with a in a terminating decimal. Okay. So 80 is such a number which is made up of 2 and 5. The number could have been like 6 upon 125, in which there is no 2, there is only 5 and 5. All right. So, okay. So, tell me, you guys, do you know about data sufficiency questions? Have you ever seen them or do you know about them? Data sufficiency questions? No? Okay, okay. No, no problem. Actually, it's not that they are not something new. It's just a different way of asking the same old question. Okay, so I'm writing down a question and you may want to make a note of it, or after I'm done writing you can just click a picture also, whatever suits you better. Okay. So okay, so P is equal to 2 to the power A, 3 to the power B, 5 to the power C, and Q is equal to 2 to the power X, 3 to the power Y, and 5 to the power Z. Okay, then the question is P upon Q a terminating decimal? This is a question. The question is not complete yet. Okay, so just wait. Okay, so then you are given information in pieces. First information says that A is less than X, but B is greater than Y. Second information says okay, sorry, this is C greater than Z. Alright, so the question completes now. Let me raise the size. Okay, so the question is complete. You think about it while I write the options on the right hand side. Okay, so I hope you understand that the question written on the left hand side does not contain options. So 1 and 2 are the parts of the question itself. Now I'm going to write the options. Yes, this completes all the options. So which among A, B, C, D or E do you think your answer is? No, Himanshu, you cannot give choices. You have to choose one between A or D if you say so. Okay, so I have been getting answers. Good that you are participating. First of all, I appreciate. And the majority answers are B for Bombay. One, one or two answers are C. One or two answers are D. A couple of A answers. One is E also. D. A lot of people are answering D also. Everybody should participate. See. All right. So P by Q will have will make a number in which there is 2, 3 and 5 with some powers. Now the power of Q, uh, the power of 2 will be A minus X, the power of 3 will be B minus Y, and this will be C minus Z. Alright. So now terminating decimal is formed when we have 2 or 5 or a combination of 2 and 5 in the denominator. So we are asked if our number P by Q is a terminating decimal or not. Now there are many aspects to this question. Through this question, I also tried to introduce you to the amazing kind of questions which is data sufficiency. Okay, so there there are a lot of thoughts, schools of thought behind answering this question. So let us see the first statement alone. So it says A is less than X. So that means this number P by Q will end up having something 2 in the denominator, say to the power n. Similarly, C is greater than Z. That means it will have 5 in the numerator, say the power is m. But we do not know anything about 3, if it will be in the numerator or in the denominator. So if you have no clue about 3, where is it? Is it in the numerator or in the denominator? Will you be able to say with full confidence if P by Q is going to be a terminating decimal or not? I don't think so. Okay, so the first statement is not sufficient. Okay, the first statement is not sufficient. First statement said nothing about 3 and it was imperative to know about 3. So first statement is not sufficient. Okay, let us forget what first statement said. Now with blue color, I'll write what second statement says. Second statement says B is greater than Y. So this tells me that P by Q will definitely have 3 to the power whatever in the numerator. But we do not know where 2 and 5 will be. Now the critical question is, does it matter where 2 and 5 are? Say 2 and 5 are both in the numerator itself. Is it a terminating decimal? Yes. Or they are in the denominator. Will it still be a terminating decimal? Yes. What if 5 is in the numerator and 2 is in the denominator? Terminating decimal? Yes. What if 2 is in the numerator, 5 is in the denominator? Will it be a terminating decimal? Yes. So in all the cases, we are getting a solid answer. Yes, it will be a terminating decimal. So I think it is clear now that this piece of information was vital. The placement of 3, whether it is in the numerator or denominator, knowing this was important. So I think we have our answer, that statement 2 alone is sufficient to answer the question, but statement 1 alone was not. Because if a number has 2 or 5 left in the denominator, then it is a terminating decimal. But here 3 was also present. We needed to know where 3 is going to be. I hope it is clear. If it is not, please let me know so that I can explain you a little better. Sure, Asmita, I can tell you why 1 alone is not the answer. Okay, so let us see. Statement 1 alone says that A is less than X and C is greater than Z. Let us take an example. Okay, so what if A is 2 and X is 4 and C is 1? Oh, sorry. C is 5 and Z is 3. Okay, what does it tell you about P by Q then? So what do you think? So we have A is less than X. So I'm going to have 2 square in the denominator, right? And C is greater than Z, so I'm going to have 5 square in the numerator. Okay, so if a number is divided by a power of 2 or a power of 5 in the denominator, is going to be a terminating decimal. But we should not forget that there was a 3 also, and it says nothing about the position of 3. What if B is greater than Y? Then 3 is going to be in the numerator, and yes, then it will become a number divided by 4. Then the answer will be yes. But what if B is less than Y? Then I'll have a number in which there is not only 2 or 5 in the denominator, but also 3 is there. 3 is also there. Then the answer will be no. Because do you ever get a terminating decimal when you divide 1 or 2 or 10 by 3? No, right? So therefore, statement 1 alone is not letting me decide if it is going to be a perfect yes or a perfect no. Alright, so let us see how second alone will decide that this is going to be the answer. Okay, second says nothing about 2 or 5, it talks only about the powers of 3. So B is greater than Y. Let me take B as 4 and Y as anything 1, 2 or 3. In that case, P by Q. I do not know where 2 is, where 5 is, but I surely know that 3 is going to be in the numerator with the power 1 or 2 or 3, whatever. I have no idea where 5 is, where 2 is, but I'm sure that it will be either in the numerator or in the denominator in any combination. So tell me, if both 2 and 5 are in the denominator, will it be a terminating decimal? Yes. If they are in the numerator, will it be a terminating decimal? Yes. If one of them is in the numerator and the other in the denominator, will it be a terminating decimal? Yes. So this statement alone is allowing me to answer the question with uh, an undoubted confidence that yes. All right. So let us move ahead. Okay. Next thing is recurring decimal. So I hope you have made notes about terminating decimal. Okay, new thing now, recurring decimal. Okay, what are recurring decimals? Every one of us must have seen numbers which never end, after decimal especially. So the numbers like 3, 3, 3, 3, 3, and so on. They make an endless loop, or like 2, 1, 2, 1, 2, 1, 2, 1. So these are called recurring decimals, which have an infinite loop. So Himanshu said pi. Interesting example. So pi also is a number in which the decimal never ends. So these are not terminating decimal. But Himanshu, we'll just learn in a while that pi is not a recurring decimal. Pi is not a rational number. Pi is an irrational number. We'll talk about them. Okay. So just give it time. Okay. So if we just think how these numbers must be formed, what leads to the formation of these numbers? These numbers the result of a division? Yes, isn't it? They are always result of a division, like a terminating decimal is. It's just that the decimal never terminates, the division is never complete. Let us think about zero point 0.3 is an easy example. Let us think about this. 1 divided by 3. You put a decimal, it becomes 10, then you put a 3, and again 1 is there. This is an infinite loop. This goes on. So this is what makes 0.333. So this was easy. 0.333, everybody knows that when you divide 1 by 3, you get 0.33333. But what about the second decimal that I wrote? 0.21212121. Nobody has mugged up these numbers, how 21 will be formed, what divided by what. So that is the technique that we are going to talk about. Fine. Okay, let us see what you guys have to say. Hmm. Okay, so there is a technique to know what was the division which led to that recurring decimal. Okay, let me take the easy most example first. So suppose there is a number, I call it x, which was 0.222 infinitely many times. Okay, so I want to know what divided by what. So when you divide two integers, there's no decimal, right? Either in the 10 or in the 3. So I want no decimal here. I want to end the decimal. But multiplying x by nothing will make me end the decimal. It seems so, at least right now. What I'll do, I will create a number from x which will have the same thing after the decimal. So I multiplied x by 10. Now I have 10x, which is 2.22222. So post decimal, the number is same. Now I'm going to subtract the two of them, and I get 2. This is exactly what I wanted. I did not want decimal, so x became 2 by 9. So you guys please check in your mobile phone calculators. What do you get if you divide 2 by 9? You should get 0.2222 endless 2's, isn't it? Okay, so the idea was to eliminate decimal by subtraction. Had we known what multiplication would eradicate the decimal, we would already have had the answer. But we didn't know. So we tried to create a number by the virtue of subtraction so that we got no decimal. Okay, let me try the next number. Okay, so y is 0.2 21212121. Okay, now if you mug up from the previous example, the next example is always going to be a problem for you. Now, if you just saw that last time I multiplied by 10, this time also I should multiply by 10. So I would get what? 2.121212, and then you subtract like I did in the last time, in the last question. You are not going to get 0 after your decimal, isn't it? So what do you think? Should we multiply with y so that I get the same thing after my decimal? So this time it is going to be 100. 100y is 21.21212121 and so on. So 99y is going to be 21 and y is going to be 21 by 99, 7 by 33. Guys, please check in your mobile calculators, divide 7 by 33, you should get 0.212121. If anybody doesn't, please let me know. Okay, so I think you got the idea, and I'm now going to give you a recurring decimal, and you have to convert it into fraction and let me know. All right, so I'll solve all of them after you try this. Sure, Abhishek, we do have a shortcut trick for these kind of questions, but it is imperative to know the longer method first, because the longer method always has the basics, okay? And it is a must to have basics in place. So just patiently, let's do one or two more questions by the longer method, by the basics clear, having the basics clear, and then I'll tell you a shortcut so that you just get the answer like in a moment, in a second. So, okay, please tell me point 134 and bar. Bar means this is the link which is going to be repeated. So it means 0.134, 134, 134, 134. So guys, I think this would not take time. Great, we already have like 4 or 5 answers. Great, 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 great. Very good. Very nice. So everybody is getting 134 by 999. I think you have already got the pattern. That is amazing. Okay, so I see that everybody gets the answer and the correct answer. Now I will move ahead after 15 seconds. Anybody having a problem in getting the answer as 134 by 999, please let me know quickly. Just write problem. Don't write the entire problem. Just write problem and I'll hold for you. So if this is x, this is going to be 134 by 999. I'm not explaining it, considering that everybody got the answer. Abhishek didn't get it. Okay. Okay. No problem, Abhishek. For you, okay. So first of all, let's understand what this bar is. It's 134, 134, 134, 134 infinitely many times. So I want to multiply something with x so that I do not get the same number, yet I get the same decimal, same trail after decimal. So I want the entire trail of 1, 3 and 4 to the left of the decimal. So I will multiply 1000 with x. So we get 134.134.134.134. Okay, so if I subtract x from 1000x, so I get 999x and no decimal on the right hand side. So x becomes 134 by 999. Yes, so Abhishek and anybody else, if at all, please tell me if you still didn't get it, or you have problem in a particular step. Great, great then, fine. Okay, next is going to be a little harder than these. So what if the number is n and it is equal to 0.231313131. So 31 is the recurring part, 2 is stationary. Okay, tell me then. Don't be in a hurry. In the beginning, the emphasis should only be the right answer, the accuracy, not the speed. Speed you will automatically get in a while. Okay, we have started getting the answers. Hmm. Interestingly, I have got 3 answers till now, and all the 3 answers are different. 5 answers till now. Okay, I'm going to write these answers for you so that you get an idea what variety we are getting as answers. So one is 229 by 900, 990, I'm sorry. One is 231 by 999. Okay, one is 77 by 33. One is 231 by 99. Okay, one is 229 by 98. Look at the variety. 229 by 90, etc. All right. Okay, so we have got the idea. Kacha pakka. Little bit yes, little bit no. So that's okay. That happens. Okay, so what do I do now? Okay, so I want a zero after decimal. Okay, so I know what is to be done, but let me behave like a rookie, like a new person who has just been introduced to this concept, like most of you. Okay, so if I just multiply this by 10, I get 2.313131. So this does not help. This does not help. So this subtracting this from n or n from this is not going to give me a, okay. So if I multiply 1000 thinking that oh god, this also does not help. So that puts me in a fix now. So if I subtract this, it will be like no respite for me after decimal. So this 2 is creating a problem. This 2 after the decimal is creating a problem. This one. Okay, so first let us get rid of this. By getting rid, I mean let's put this in the new in the before the decimal. So okay, I have to find the value of n. But now I am going to consider that my question is this 10n is my question. Okay, so now I have only the recurring part after the decimal. Now I'm going to multiply this 10n by 100 and I get 231.3131 and so on. Subtracting these two, I get 990n as 229.0, because of which I get n as 229 upon 990. Okay, guys, I would like to just help you recall that this is an MDC class, math development class. The pace is a little slower than the normal class. Okay, so when I take the normal class of numbers or the problem solving of numbers, or a workshop, the pace will be different. Okay, so here the emphasis is on uh, concept building and strengthening the basics. Okay, so the answer becomes 229 by 990. All right, so this is it. Okay, so let me now come to the shortcut part. Can we? So we are clear how and why 229 by 990 was the answer. Fine. Okay, so I'm going to write a few numbers, all recurring decimals, and then we look at the shortcut so that we do not have to every time assume every number as x, then multiply it by 10 or 100 or 1000 and then subtracting, and it's always a 3 or 4 step question. So now how to just immediately know what divided by what is going to give me the answer. So let me take examples. So point 7 bar point 31 bar is only on 1. Point 327 bar is only on 27. Point 5314 bar is only on 14. 2.326. Okay, so what is the shortcut? Let us see. Okay, let us take the first one right now. So we first decide the denominator. Okay, so how many distinct digits after decimal? Only one, and that is a recurring digit. So I will have 9 in the denominator. Okay, what about this one? So it has two digits, one recurring, one non-recurring. As many nines as the number of recurring digits, as many zeros, as many non-recurring digits. Okay, point 327, the bar is on 27. So two nines and one zero. Okay, here we have two nines and two zeros. And here we have two nines and one zero. So we have to learn making the decimal first. Okay, so as a note for you, let me write. So first step is make the denominator first. Okay, and how? Write as many nines as there are recurring digits and as many zeros as there are non-recurring digits. Fine. Okay. So we have made the denominator like this. Then second, make the numerator. How do we make the numerator? Shortcut. Write the entire number ignoring the decimals and subtract the non-recurring part. Okay, let me explain to you how. Okay, so I write the entire number 31, so 3275314 and subtract the non-recurring part. There was no non-recurring part, so I subtract 0, I get 7 by 9. Here there was a non-recurring part 3, so it became 28 by 90. Here there was a non-recurring part in the third one, it was 3, so I get 324 by 990. I had the non-recurring part 53, so I subtract 53 from 5314. Okay, what do I get? I get 5261 upon 9900. You may check if you are getting these kind of decimals or not. So 323 upon 990, right? So this was the so-called shortcut made up of these two uh, steps. You may want to note down the steps before I move ahead to the next deal of questions. Okay, so I'm going to write a question for you. Okay, pausing the video over here. I'll write the question elsewhere, and I'm pausing so that you have this page before you for a while. So if you want to just note down something, you can while I write the question for you. So just give me a minute, and you also take a minute to make your note. Okay, guys, just 15 seconds to me. All right, I'm done writing the question. Here is the question for you. Everybody can see this. N is equal to 0. ABC, ABC, ABC. Where A, B, C are digits. Hi, sorry, it was muted. So, yeah, I had been speaking. Okay, so I was saying that slowly and gradually I have been getting the answers. Everybody has answered. A lot of people have answered. I got almost all the options as answers except B option, B for Bombay. And I have no idea why people have rejected B. Many people, a lot of people are answering A option. Many people are answering C. Some people are answering D also, which makes the question a star because when all the options are equally answered, opted by the people, it is really, really confusing. That means it is really, really confusing. Okay, so we are told that A, B, and C are digits. We are not told that A, B, and C are distinct digits. Okay, so but we are asked definitely it should result in an integer. So I have to take the worst case, and the worst case is ABC will be different. So what if n is a kind of number which looks like 321, 321, 321, 321, 321. Okay, so you know what it is? 321 divided by triple nine. Okay, so the thing was, what do you multiply by n so that it makes an integer? So definitely you cross multiply. So 999n. will definitely make it an integer. Okay, you have seen that 999 is needed. If you don't put 999, you only place 99, it will not serve the purpose, will it? Okay, so if you have any doubt, you just take out your calculators, your phone calculators maybe. So you make a recurring decimal. Okay, so you make a recurring decimal. Okay, and then in which there are three recurring digits, and then you just multiply it by 99 or 990 or something like that. You are not going to get an integer. Okay, so 999 will surely make it an integer. Okay, what about 9000? Do you know when you multiply only 1000, so 1000n is going to make it okay 321.321 bar. Okay, so it will be like 321 plus 321 by 999. Agree? This is 1000n. What about 9000n? If you multiply the entire equation by 9, you get the left hand side as 9000. Are you sure you are going to get right hand side as an integer? I don't think so. Therefore, 9000, the first option, a trappy option in your case, is cancelled, discarded. Okay, 1980. There must be something about 1980 which is special that made it an option. So if you factorize, you find it 1980 is actually 2 times 990. So the root is 990. So they wanted to give you 990 as an option. It would have looked too simple, too easy, so they just multiplied by 2. The idea is you have to multiply any of these numbers to get an integer. Okay, so 990 will not serve the purpose because we may have all the digits distinct. So I needed 999 into something. So therefore B option is also gone. Okay, B option is gone because I need an exact number of nines. So what 999 will do, 999, sorry, 9999 may not do, will not do. Okay, so I'm left with 3996 by the process of elimination. And if you just factorize 3996, it makes 4 into 999. So 999 was needed. Anything except 999 is most welcome. So only if 999 was multiplied, my number was going to become an integer. And if 999 into 2, 3, 4, 5, 10, 20, 100, anything, it will also surely make it an integer. Is it clear to you guys? No? Okay, we shall see. Okay, so we know that if A, B, C are distinct, like I took the example 321, 321, n is going to become 321 upon 999. Okay, here I took an example where it could be, simplified by a factor of 3, but let us not bother about it because it may or may not. Okay, so now instead of writing 0.321321, I would write 321 by 999. Okay, so now let us take the first option. Multiply it by 9000. Does it get you rid of the denominator? I don't think so. The triple one, at least triple one will still be there in the denominator. Do you get rid of the denominator? No. Okay, so first option is disregarded. Okay, second option 1980. Let me write it like this: 2 into 990. So our n was 321 upon 999 and you multiply it by 2 and by 990. Will you get rid of the denominator? No. Third option is 4 into 999. Will you get rid of the denominator? 100%. So third option becomes the answer. Also, let us look at the fourth option, which had more nines. So we have one more nine than required, tetra nine. So will you get rid of the denominator? No. So only third option has to be an answer. Yeah, Himanshu, you are absolutely right. We need to basically find an integer multiple of 999. All right. So I suppose this was a satisfactory question since it got a lot of you wrong. All right, guys. So this was the concept of recurring decimal and terminating decimal. Not regularly asked, I admit, but you never know which exam might make a question out of this, because this is something from the very basic, from the core. The core is division and remainder and terminating decimal, and all these things are very important. You might forget these names but not the basics. Okay, in the leftover time, we have 15-16 minutes left. I want to utilize this into something very, very special, important, and I want you to learn some shortcuts to immediately calculate LCM HCF of numbers. Okay, so when we talk about calculating LCM HCF, there could be two or more than two numbers, like find the HCF of 48 and 72, or find the LCM of 90 and 108, or 36 and 45, LCM HCF, 36 and 25. So there could be more than two numbers also, but let us first learn to deal with two numbers like quickly. So if I'm not wrong, if you are asked find the LCM of 36 and 45, most of us start making this, and then we see it is divisible by 3, then we write 12 and 15, then another 3, then 4, then 5, and then 4 ones, and then 5 ones, right? A lot of us find it very irritating, very time taking, and we want to get rid of this, we want to get the answers faster, but this is the only method that we know. So this is it. Okay, so we get the LCM as 3 into 3 into 4 into 5. Okay, which is 20 into 9, 180. All right. Okay, so I'll come back to this example. So, was I right on this? Everybody knows this method, at least this method, if not much. Okay, okay. So I have categorized, whenever you are given a pair of numbers, there could be three cases. Okay, so I would not make it very technical for you. I would rather try to explain it to you through examples. So case one is this type, 9 and 36. That is, what is the type? What is so special about this type? So what is so special about this type is one number is divides the other number completely. Okay, so this is the type. Okay, if this is the type, then you have nothing to worry about, because it is the easiest type. So you do nothing, you just tag the smaller number as the HCF, and the larger number as the LCM. This is like for sure, and this has no exceptions, right? So only the larger number is the LCM. A smaller number has to be the HCF. All right, should be clear by now. Case 2. Case 2 is completely opposite of case 1. It's like 4 and 9. So what is the recognition? Okay, coprimes or having nothing in common except one, obviously. So there is nothing to mention except one, because everybody knows we cannot prevent one from being common. So okay, so 4 and 9. In this case is also easy. So here HCF is simply 1 and LCM is the product of the two numbers. All right. And then comes case 3. Case 3 is the most frequent of all the cases, where neither one number is a factor of the other number or a multiple of the other number, nor they are coprimes. The numbers are something like this: 12 or 12 and 18, or 12 and 15, or 9 and 12, right? Or 6 and 15, or something like that. So I hope you understand, this is neither case 1 nor case 2. Neither they are coprimes nor they have everything in common. So what happens in this? It will be a little more interesting for you now. Okay. So in between, I would deviate for a second and will write something. So in case of two numbers, let me say A and B, the LCM into HCF is equal to A into B. Always, always, in all the cases, right? This would be like all the cases. So you may want to make note of this. This is going to be all the cases, okay? So, so this case, and this case, all refer to this, all confirm you this. Okay, okay. So yeah, coming back to my problem. So let us find HCF first in this case. So HCF in these cases is the difference, but the story is not over, or a factor of the difference. Okay, let me take case by case. Okay, let me explain it to you first. So let me take the first case, 12 and 18. What is the difference? 6. Are the two numbers divisible by 6 each? Yes. So 6 becomes the HCF. Okay, Another small point, you do not have to check both the numbers. If one is divisible, the other will also be divisible. So you just check once. If 12 is divisible by 6, yes. So you find the difference and you check one of the numbers. If it is divisible by the difference itself becomes the HCF. But this will not be the case every time. Okay, in 9, 12 also this is the case. The difference is 3 and the numbers are divisible by 3. So 3 becomes the HCF. But let's take this 6 and 15. The difference is 9. But definitely 9 cannot be the HCF. 9 is bigger than one of the numbers itself. So we start considering the factors of 9. So definitely in 6 and 15 are not divisible by 9. So factor in decreasing order. After 9, 3 is a factor. Are the two numbers divisible by 3? Yes. So 3 becomes the HCF. Okay, let's take more cases. More cases. Don't worry, you'll all understand this completely. Okay, so let me take 3 cases. We have already taken 12, 18. I'm going to take 14, 20, 15, 21. So the difference is 6. Difference is 6 in both the cases. Another case, 13, 19. Difference is 6. So just trying to tell you that difference alone doesn't work always. So difference is 6. But are the numbers divisible by 6 in the first case? No. 3? No. 2? Yes. So 2 becomes the HCF. Are the numbers divisible by 6? No. 3? Yes. So 3 becomes the HCF. Right. And this you already know. This is our second case. The HCF is going to be 1. But this will still work. Are the numbers divisible by 6? No. 3? No. 2? No. 1. Then 1 becomes the HCF. So this logic will work across all the cases. Alright. So just in case the numbers are filthy big, but it is easier for you to find the difference. So if you are asked to find the HCF of 870 and 835, whatever way from your earlier references to find the HCF. Now this is going to help you the most in this case. HCF is either 35. Are the numbers divisible by 35? You'll have to check. So you may not know the table of 35, neither do I. So how I'm going to check. 35 is made up of 5 and 7. So 7, are the numbers divisible by 7? Because I can see they are divisible by 5. So no, they are not. So if not 35, then it could be 7 or 5 or 1. I think there are only 4 factors. So 7 is not, then 5 becomes the HCF. Okay. So in case HCF, finding out HCF is easier for you. You already know the numbers. And now you know the HCF also. And putting into this formula, you can find the LCM. Okay. There is also a so-called shortcut to find the LCM also. In this case. But if you just quickly confirm that you got the idea of finding out HCF through differences, I can just take on the LCM part. Is it okay? HCF is either the difference but not a promise. In case the difference is not dividing the numbers, you find out factors of difference and then you may start working on it. There are other methods also, so I'm not going to depend on this method. This is like since it is a math development class, I thought of sharing it with you. We have other methods. When we study numbers as a full-fledged chapter, I will take it, or whosoever takes your class will take all the processes. Okay. So, all right. What about LCM? So, suppose 12 and 18. So you pick the bigger number, you recite its table in your mind, till the point the other number starts dividing. Does 12 divide 18? No. Does 12 divide 36? Yes. So 36 becomes LCM. Alright, let us see in case of 9 and 12. Okay, we pick the bigger number. We start reciting the table. 12, is it divisible by 9? No. 24, is it divisible by 9? No. 36, is it divisible by 9? Yes. So 36 becomes HCF. 6 and 15. The table of 15 in my mind. So 15, is it divisible by 6? No. 30? Yes. So 30 becomes the LCM. Alright, sometimes the numbers may be a little too big for you to be able to find, to be able to recite the tables. So let me take the example 90 and 108. So you will need to, according to the law, you need to now recite the table of 108, but you do not know the table of 108. So what you can do, you can just take something common, which is easily observed. So 10 and 12. So you can just now take the table of 12, 12, 24, 36. Yes, so 36 becomes the LCM, not 36, but 9 into 36. So 9 into 36 becomes the LCM. Just give me a second.